answered now. Thank you very much.
Thank you very much, sir, for your inspiring words and constant support in encouraging knowledge and growth. So we now move on to a moment of sincere gratitude, the felicitation ceremony. As a respectful gesture of our heartfelt appreciation for the esteemed presence of our distinguished dignitaries. May I now request Mr. Tarun Bhattacharya, General Secretary, BCRC Society, and Sri Jarnal Singh, Treasurer, BCRC Society, and Professor Shaukat Mukher, Advisor, to felicitation ceremony. May I now request Professor Selin Shina Chaudhary to accept the humble token of appreciation. May I now request Professor Dejani Mitro to accept the gesture of honor and respect. May I now request Professor Nandini Mukherjee to kindly receive the acknowledgement of her precious presence. May I now request Dr. Ranjini Menon to accept the humble token of appreciation. May I kindly request Dr. Manjula Sinha to accept the token of sincere gratitude. Thank you to all our faculty members and heartfelt thanks to our esteemed guests for graciously accepting this token of respect. May we now request our esteemed dignitaries to kindly step onto the dais and grace the occasion with their presence. Professor Shelly Sinha Chaudhary, Chair, IEEE Women in Engineering Affinity Group, Kolkata Section, and Professor, Department of Electronics and Telecommunication Engineering, Jadavpur University. Professor Nandini Mukherjee, Senior Member, IEEE and Professor, Department of Computer Science and Engineering, Jadavpur University. Professor Devjani Mitra, Chairperson, Career Development Center and Professor, Department of Electronics Engineering, IIT ISM Kanpur. Dr. Ranjini Menon, Scientific Officer at Variable Energy Cyclotron Center, Department of Atomic Energy, Kolkata. And Dr. Manjula Sinha, Senior Scientist, CCS Research and Innovation, Kolkata. Let us welcome them all with a warm round of applause. Now we take great pride in welcoming Professor Seli Shina Chaudhary. She is a professor in the Department of Electronics and Telecommunication Engineering, Jadavpur University. She did her undergraduate, postgraduate and doctoral studies from the same. She has served at the department as a faculty member since the last 26 years and as the head of the department during 2018 to 2020. She is actively involved in taking UG and PG courses, documentation of department data in the induction program of first year students. She is involved in the development of the IC design and fabrication center of the department, raising funds through the alumni to upgrade the departmental facility. She designed a summer training course on embedded systems and IoT and developed two research labs, the Computer Vision and Data Analytics Lab and the IoT and Embedded ML Lab. She has participated in various programs under TEQIP2 and TEQIP3 and in various schemes under JU Russia 2.0. Her main research interests are digital image processing, computer vision, machine learning, deep learning algorithms, biooptimization algorithms, and embedded vision. Her research has resulted in a number of research publications of over 200 PG and PhD. She motivates students at all levels to participate in technical competitions. Currently, she is involved in research collaboration with University DFB Paris and NIT Meghalaya. She is a member of ITI and IEEE, currently holding the post of Chair, Women in Engineering Affinity Group, IEEE Kolkata Section. Ma'am, may we now request you kindly take the podium and share your award system with us.
Thank you. Good morning, everyone. I take this opportunity to thank the organizers of SIACON 2025 for hosting the V session and giving me as a V chair an opportunity to talk about the most active and vibrant affinity group of the IEEE Kolkata section. Shrikot sir has already given you an idea about IEEE, and let me reiterate that this is the biggest technical professional body of engineers across the world. So, the students who have become members, they will soon realize the benefit of belonging to this network, but be sure that you take active participation in the calls that are there. You may be getting the notification once you become the member and try to participate at the various competitions and events that are organized all through the year. Just because students are not members, they may be skilled at one or more opportunities or one of the most happening topics like the robotics, like data analytics and something else, but you miss the chance to participate in these events just because you are not members. I have seen at the global forum that many students from many institutes, they cannot come and very few student participants are there, and this is not a very healthy competition when very few teams are there at the national level. So it is not very difficult to go to the national level to showcase what you know, to showcase your talents. And even the participation part, you may not be a winner, but even the participation will give you a flavor of what students like you are thinking in our country, how they are preparing themselves, how they are doing their research through their projects and so on. So it gives you an opportunity to take part at such events, starting from the regional levels and then on to the national levels. And if you are good at what you are doing, then one of the lucky teams gets selected to represent the Kolkata section at the region 10, that is R10, the Asia Pacific region of IEEE. And you will be sponsored to go to the country where the event takes place, and you will be able to get to meet students from universities from other Asia Pacific region institutes. So this gives us an opportunity to explore what we can do, and also by organizing programs you get the flavor of how organizing programs can be done. Your teachers will be there with you, so you just need to think of events. You can start from local levels, you can organize events among yourselves from different departments, not necessarily you will be going at inter-institute programs right at the beginning. So you can talk of very simple things. You can organize seminars among yourselves, you can organize poster sessions among yourselves, and ask your teachers to award the winners with a certificate. That is very good, because that you will be able to show later on in your lives, and maybe little gifts which wouldn't cost much. But the idea of competing among yourselves prepares you to face challenges when you pass out from your institutes. It makes you ready for the high competition we face in the technical career fields. And also, we, that is women in engineering, is not only about the technical aspect, but IEEE itself has the motto of working for technology for humankind, for human benefit. So it's our job also to take awareness to school levels, so that school children can be inspired to follow STEM careers, and also to inspire in them the confidence that yes, things are possible if I believe in myself. So all the students here sitting in this room, they have been able to come this far because of, mainly because of family support. I know without family support, hardly many of us can go forward or can join these kind of colleges and prepare ourselves for the global market. But if we can go to the schools, especially where the parents might not be very much learned, schools like that, and if we can instill this confidence in the little children that yes, they can also come this far where we have been able to come, then we can make a difference in the ecosystem of our state, of our country. And it is very much necessary for the overall development of the country. So we shouldn't be engaged in only preparing for our careers. It is very important, I know, as students, but we should also think of sharing that these kind of things are possible for people whose parents might not have gone very far, whose parents might be doing very ordinary jobs, but the students should be able to think big. They should be able to think that yes, I can do whatever I dream of, and they should be helped to dream also. So these are my few words about the student volunteers, and whoever has not yet become IEEE volunteers, please to become. It costs only about 1,000 rupees for a year. It is not much if you break it up into monthly expenses. We are spending on so many things. I'm sure we can spend a little bit more to become members of this kind of global organizations where the participation in the different events helps us to move forward with our career choices as well. Thank you.
Thank you, madam, for such enlightening words on the facilities of being such a biggest athletic group that is IEEE. Your insights that the students should not stop dreaming. They should be rooted and they should always think about something out of the box has always made our students improvise. Thank you, ma'am. We are truly grateful for your time and wisdom. Let's all thank ma'am with a great round of applause.
Now, it's our privilege to invite Professor Nandini Mukherjee, one of our most distinguished guests, to address this august gathering. She is a professor in the Department of Computer Science and Engineering at Jadavpur University, where she has been teaching since 1992. She earned her BE in Computer Science and Technology from Bengal Engineering College, Shivpur in 1987, followed by an MCSC from Durgapur University in 1991 and a PhD in Computer Science from the University of Manchester in 1999 with research focused on feedback-guided standardization. Dr. Mukherjee's academic career spans over 3 decades, during which she has actively taught undergraduate and postgraduate courses, guided numerous master's and PhD students, contributed to curriculum and laboratory development, and served as a member of the Faculty Council of Engineering and Technology and the Executive Council. She has published over 250 research papers and supervised projects funded by various Government of India agencies. She is an active researcher in her research areas, which currently include high-performance parallel computing, wireless sensor networks, and Internet of Things. She served as the Director of School of Mobile Computing and Communication, Jadavpur University, for nearly 6 years, and the head of the Department of Computer Science and Engineering, Jadavpur University, for 2 years. She has been involved in organizing many international conferences, workshops, and seminars. Beyond academia, she is a senior member of IEEE and IEEE Computer Society, member of the ACM, a light member of the Forum of Scientists, Engineers, and Technologists, and serves as the Secretary of the Free Software Mancha, West Bengal. Ma'am, may we now request you to kindly take the podium and share your valuable words. Professor Nandini Mukherjee will deliver with us a technical talk on AI and high performance computing. Thank you, ma'am, for coming.
Okay, very good morning to all of you. Very good morning. In fact, it's not yet afternoon, morning, because not yet 12, right? Okay. So actually my responsibility was to deliver a talk and I have selected this subject. Yeah, as you can see, role of HPC in the world of AI. So my first question is, how many of you are from final year? No one. Third year? Lot of students are from third year. Second year? Few. First year? Not yet admitted, no? First year. So yeah. So we don't have any first year students. Third year students, do you have knowledge of AI yet? Have you started? Not yet. Third year means just past second year, right? Okay. So maybe I will be speaking about something which you do not know yet. I'm trying to explain some technicalities according to your understanding. I hope this will be okay for you, my lecture at least, not too technical, because I'm not an expert in AI. Not at all, right? HPC, some of you perhaps know, HPC means high performance computing. I did a little research on high performance computing, but in the world of AI, that means artificial intelligence, that which is all of you know. Okay? So everyone is interested in artificial intelligence nowadays. Everyone is talking about AI, right? And no one wants to learn any other subject. So we will talk about AI shortly. So whenever I try to give any project in any other domain, because I am not an expert in AI, so I try to give any project in any other domain to my students, they tell me, no madam, I want to do something in AI or machine learning. So AI and machine learning have become the buzzwords in the world now, right? So let us talk a little bit about AI. I'm not going to speak any technical details, but I would like to start from a paper in 1950, which was published in 1950 in the magazine Mind and was written by Alan Turing. How many of you know about Alan Turing? All of you, I believe. You know about Turing machine? Right? So Alan Turing, he was a great mathematician, computer scientist, and he also worked for coding, for breaking codes, etc. Right? So there are a lot of contribution of Alan Turing. I feel that he is a great computer scientist who pioneered in computer science, actually, theory of computing as well. You will learn about Alan Turing when you will study theory of computing. So in his paper in 1950, he first said, you can see the quotation, I propose to consider the question, can machines think? So that is what Alan Turing started saying, and he wrote a lot of things in this paper, and I think this paper is actually, you can say, the beginning of the research in artificial intelligence. Though he didn't use the term artificial intelligence, he used the term machine intelligence, right? But he first asked the question, I propose to consider the question, can machines think? And he explained how that time, in 1950, we have just started working with computers. The first stored program computer was built in 1949. That is in Manchester, my university. So in my, I always say that is one of my university, other than Durgapur University. So in University of Manchester, the first stored program computer was built. Stored program means you can store a program And the computer which we know nowadays, you can store a program and every instruction will be executed from the memory and we will get the result. Okay. Before that, it was just like a calculator. So people are just giving an instruction and computer is giving the output. It was like that. But then this computer was invented in 1949 and Alan Turing, that time, don't think about that time, we never had the mobile phone, desktop computers, laptop, etc. But he said, how do we make a computer think? And he explained 3 different states through which a computer must move so that a computer can be made thinking like a human being. What are the 3 states? The first state, the initial state, you can see the first state, the initial state of mind, say at birth, the education to which it has been subjected. You all are being subjected to an education, right? Through your college, schooling days, through your college days, you all are subjected to an education. So, the machine which will be, the education to which it will be subjected. And the third state is other experiences not to be described as education to which it has been subjected. Like when a child go to some hot utensil or something, and when the child touch that utensil, the child understands we should never touch any hot thing, right? So that is through experience. A child learns through experience. So a child always moves through these 3 states, and if we can input these 3 states inside a computer, then possibly we will be able to make a computer think like a human being. That was Turing's description of an intelligent machine. Then there was a conference or workshop, whatever you say, in 1956 at Dartmouth, right? At Dartmouth, again some greatest computer scientists, including John McCarthy, Minsky, Rochester, and Shannon. If you have learned about Shannon's theory, so Shannon was also part of this team, and there were other scientists also. So in this workshop, the term artificial intelligence was coined for the first time, right? And I again would like to quote from McCarthy, from this proposal which was written by these 4 persons. There McCarthy said, we will concentrate, so he is describing how an intelligent machine would be. We will concentrate on the problem of devising a way of programming a calculator. See, he is saying programming a calculator, right? To form concepts and to form generalizations. So that was the description of artificial intelligence in 1956. So if we go back to the state of 3 states described by Alan Turing, then if we consider the initial state of the mind at birth, what is the computer at birth? When you get a bare machine without any software, just OS installed, the computer device with the OS installed, that is the computer at birth, right? And now we need to educate the computer. So, the education to which it has been subjected, like a child. We educate the computer, which we can say supervised learning. Supervised learning, I'm not going to explain these details, but again, software through which we educate the computer. Like, we show several photographs of cats and dogs, say cats and dogs. And every time, like a child, we tell the computer, this is a cat, this is a cat, this is a cat, with different colors, different postures. We can teach the computer, this is a cat. So when a new image of cat comes, a computer will be able to understand that this is a cat. So this way actually we develop a software for teaching a computer, right? So that is an education through which a computer may pass through, okay? And then other experiences not to be described as education to which it has been subjected, I think that may be considered as sensors through which a computer can learn about the environment at Durgapur today, atmosphere, temperature, humidity, or maybe a camera fitted in this room and the camera can get data about all the participants listening to this lecture, right? So all these sensors can be used and we can consider Internet of Things and maybe another method of learning which we call unsupervised learning. Through all these processes, a computer can gather experiences from its environment like a child and may learn new things. Right? So, whatever Alan Turing said in 1950, now we, the human beings, are developing those softwares. Right? So, following the same three steps, the bare machine, then some education, then some experiences gathered from the environment. So these three steps, we are now trying to develop software, AI software for making a machine intelligent. Right? So, I'm not going through the entire history of AI. You can see we have different phases. Chatbot in 1966. Now we all are using chatbot. How many of you use Siri or Alexa or something? Many of you probably. Okay, few. But there are chatbots but the first one was developed in 1966. Then we had an intelligent robot in 1972 and there are several phases. I would like to focus on a particular year, 1997. Why? 1997, a chess game, not just a single match, a game was played between two entities. One, a human being, the chess champion Garry Kasparov, and the other one is a computer, Deep Blue, built by IBM. Okay? So this is the computer, the right side one. Okay? So they played once in 1996, 6 matches. The score you can see, Kasparov won by 4-2. So Kasparov's score was 4 and Deep Blue 2. And you can see the result here. In 1997, the match was organized, and here Kasparov scored 2.5, whereas Deep Blue defeated Kasparov. That is the first defeat of a human chess champion by a computer. Deep Blue won with the point 3.5, right? And that, I think, changed the history of computer science. Artificial intelligence has come to the mainstream. Before that, we had passed through AI winter, that means artificial intelligence was not so popular. So many things happened. But this is first time AI has become the mainstream computer science subject. So why? If we consider the configuration of Deep Blue, it is not just a simple computer. It has 30 processors, 480 single chip chase search engines. All of them work parallelly. That is important. All of them work parallelly. Each node, IBM RS6000 SP computer, each having 16 chase chips. That means 30 into 16, we get 480. 1 GB of RAM compared to today's supercomputer that is very small. We have supercomputers high-powered supercomputers nowadays, but these are very small computer compared to that. 4 GB disk, which is again very small, not just processors and chips, but also they are connected with high-speed switch, because as computer science and students and other students from other disciplines, you must understand that not just processing speed, all these processors working parallelly, they must communicate at a very high speed, right? So high speed switch is also required. They process 11.38 billion floating point operations per second. Now again, this is very small compared to today's high performance computers, because now even a desktop computer can process billions of floating point operations per second. So it is again very small. But that time in 1997, it was a very high performance computer. I show you the, you can see the workflow here. The chip, particular chip was designed for chess playing. So it was a move generator, then move stack. The move, that means for chess game, each move will be generated by the move generator, right? And they will be stacked so that every time the computer can think about next future moves, which can be given by the opponent, okay? And what moves the computer should take to win. So all these things, and then evaluation function, all these were actually designed in the chip. Those who know about flowchart, on the right side there is a flowchart. I am not sure whether you can see from the last row. I'm not sure about that. But anyway, I'm just trying to explain. There is, whenever there is an entry, this particular chip just thinks whether the entry is legal or not. The entry means a step, a move, chase move, okay? Whether it is legal or not, whether it is leaf or not. Leaf means we have reached the leaf of the, that is the final move. We cannot go forward after this, okay? So there is several such things. There is a move generation phase, then there is a evaluation phase. Through this, this chip actually worked, and the chip would always tell what would be its next move based on the opponent's moves, right? So as you can think that a human brain till date cannot think so quickly all the chess moves what the Deep Blue computer could do, right? And that is why Deep Blue could defeat the chess champion Garry Kasparov. Now what is behind all these things? Why am I talking about high performance computing? Because high performance computing, HPC, is the main driving force of today's artificial intelligence models. Whatever we do, we cannot go forward without high performance computing systems, right? This the thing which I wanted to tell you today. Okay? So large scale AI is high performance computing. We need three things to build large language models. You all heard about large language models, I believe, don't you? ChatGPT, based on large language models. Because we are talking about high performance computing, so the project was strong. Power problem. So you see, everyone is afraid about this type of supercomputing systems. Actually, that is the problem in our country. We don't really have supercomputing systems in every places. Like in other countries where they can have access to supercomputing systems. Partition.
কোন ল্যাপটপ শুধু লাগানো আছে শুরু করে উপরেরটা করছে উপরেরটা চলছে মনে হচ্ছে উপরেরটা করে চলছে এটা অফ হয়ে গেলে এটা শুরু করে দাঁড়ানোর অবস্থা কারেন্ট চলে এসেছে হঠাৎ করে গরম হয়ে গেছে ধর হয়ে গেছে
Thank you, everyone, for your patience. Okay, so for high performance computing, whenever we are talking about AI models, large language models, we always need not just high performance computing, which is the middle one, but we need high performance communication. The nodes must communicate among themselves. I'll give a brief overview about machines and high performance I/O. Because we are giving as training data, we are giving images, we are giving text, we are giving videos. So whenever we are giving images, videos, etc., audio data, then obviously we need to have high performance I/O also. Because the computer will have to be educated, trained. No? So for training, we will have to give images, audio, etc. Right? So high performance I/O, high performance computation, high performance communication. All these three things we need for building, for training the large language models, even ChatGPT. I will come to ChatGPT. So large models are parallel applications. I'm not going to explain what is data parallelism. I'll just give some example. But there are different types, different modes of parallelism: data parallelism, operator parallelism, pipeline parallelism. And AI, in its current form, the experts say, would not have happened without HPC innovations, because in the 90s, lot of supercomputers, parallel computers were built, communication network was made faster, and IO also, new types of IOs develop, input-output units. And that is why we could actually make so much progress in artificial intelligence and machine learning. Not just that, although we have focused on algorithms, different types of, particularly neural network, all these advances are there. But we must not forget the core computer science, which is computer architecture, computer network. So these core computer science subjects actually contributed a lot um, in the progress of AI and machine learning. So just a very brief overview of HPC. You can see we sometimes focused on centralized, that means one single computer with lot of power, or decentralized collections. That means lot of small computers harnessed together to form a big high-end computer, right? So this is the curve actually. We started with mainframe from Cray company, then mini computers, specialized parallel computer, RISC workstation in the 1980s, and probably if you try to get history of computer science, you will get all these names. Then RISC, again MPPs, massively parallel computers, network of workstation, that is now, you can see the word now. We have PCs, all PCs actually connected in a network, LAN, that forms a cluster, and then comes grid, and then now it comes, it is cloud and GPU, right? So in the recent high performance computing, what we get is a cloud. That means the large servers located somewhere, we are just accessing the cloud with GPU. GPU, GPU chips are there. Many of your laptops may be built with GPU processors. So these are the things. So the first Cray computer was like this, where you can see it has been, compared to recent days, it is very low power. Okay, but that time this computer was designed in 1975 as a vector processor. What is a vector processor? Vector processor means you all remember about vector addition, vector multiplication, etc. So these computers could take say I am just giving an example, two such vectors at the same time, compute, different processor will compute, say we are doing vector addition. So different compute processors will add two elements from two vectors, right? So this way, each processor will perform their task, and then finally the result will be output, the resultant vector, or the resultant output may also be a scalar unit. So basically, basically here we can say this type of computers can solve the programs which we say embarrassingly parallel. That means they are actually inherently parallel. In our language we say embarrassingly parallel algorithms, which could be solved using this type of vector processors. So this was the first vector processor. I moved very quickly. We worked with vector processors till 1980s. Then we got shared memory multiprocessing. That means a shared memory. So for vector processors, they can work together. But for shared memory multiprocessing, some kind of synchronization is needed among the processors, because when one processor is updating something in the memory, because the memory is shared, right? So if one processor is updating something in the memory, then the other processor will not be able to do any such kind of updation, right? So here again, we need to be a good programmer for programming such kind of shared memory multiprocessor. I am not giving you much detail, but I just want to show this one. Here, this is like a hypercube where we have nodes at the vertices, and they all are connected, these nodes, that means processors, they all are connected through some edges. Okay, so they can communicate. So this hypercube architecture came in 1985 by Intel. So all these processors can work together, and whenever needed, they can communicate the data, they can share the data among themselves. This is a hypercube architecture. Then we got in 1994, we started working with clusters. You can see this is the first Beowulf cluster designed by uh, some scientists, Donald Baker and Tom Sterling. Actually, you know who is Beowulf? Beowulf is a poem about Beowulf. So Beowulf said, I mean, from the poem, we can quote this particular line: "Because my heart is pure, I have the strength of 1,000 men." So that is a quotation from the poem. And here actually you can see this that. Have you seen such type of CPUs? I don't think. Maybe black color, but similar type of CPUs. So these are all CPUs, right? All the CPUs are connected using some kind of network, and they all work together to solve a complex problem, complex computer science problem, right? So this is Beowulf cluster. We call it Beowulf cluster, and it achieved only 1 gigaflop per second in 1994. But since then, we actually worked with similar architecture, and finally we reached in this type of architecture where we have nodes like this connected through network, and these nodes, each node actually have different CPUs. Each CPU again have cores, because you must have heard about quad core, 8 core, 16 core machines, right? So these CPUs have cores. You can see the divided lines. There is a bus connection for these CPUs, and they all access these memory banks. Okay. Obviously, again, we need good programming knowledge to program such type of machines. Good programming knowledge means good parallel programming knowledge for programming such type of machines, right? But we depend on this type of architecture nowadays. The nodes are connected in various ways. So today's top computers, supercomputers are hybrid clusters, and actually we starting from mainframe computing, cluster computing, grid computing, and then we now reach cloud computing. The servers are also very similar to this one. Only difference in nowadays, now I come to the recent trends. We have massive data processing tools, complex machine learning algorithms, increased computing capacity to train larger and more complex models faster. So because of this, now we are collecting data. We have a lot of sensors everywhere. We have social media. We have sensors. You all of have cell phones, maybe 2 or 3 cell phones with some children nowadays, and maybe us also. We have GPS. We have, when we purchase through e-commerce, then also we are gathering data. We always browse World Wide Web, emails, media streaming, healthcare, and Internet of Things. All these devices and all these platforms are generating huge amount of data, okay? And we process using modern machine learning tools. And what we get is a new type of applications, like maybe some virtual reality, maybe some other like smart city, traffic control, intelligent transportation, agriculture. So we get very new applications, not just artificial intelligence. We are collecting data. This is a warning. To finish as early as possible. Okay. Yes, sir.
currently the power power.
Visible? Okay. So new type of healthcare solutions. Even we are doing surgery now using artificial intelligence, personalized medicine. We are doing research. I mean, world is doing research on that also. Based on your gene structure, personalized medicines will be advised. So, lot of research is being done, but mainly now it is actually based on huge amount of data. If we cannot process huge amount of data, then probably we won't be able to do any innovation nowadays. So everything is based on data, and data is obtained through different ways, starting from social media to Internet of Things. Okay, we all are using some kind of sensors nowadays. So I call it democratization of high performance computing. Sometime, maybe 30 years back, HPC was done by only few persons who were good at programming and possessed very large architecture mainframe computers. But now, you can use cloud computing because cloud offers HPC access. You can always get data. Big data applications are there. So I didn't explain data parallelism, but I think you will understand the meaning if you search the internet. But big data applications are there, so you can always exploit data parallelism. GPU computing. So GPU, it's a very powerful processing unit which has become available nowadays. Were invented as graphics processing unit, but now became available to everyone. Artificial intelligence goes mainstream, I already mentioned. From the data center to edge for service delivery, caching, computing upload, IoT management, we can actually now use high performance computing for different purposes. So that you can say democratization of HPC. HPC is available for many of us if we want to use. This is just a screenshot for top 500 supercomputing list, and this fourth one, that is a computer Azure in United States. That is fourth. I mean, every time 500 supercomputer list is published every year. Okay, Azure is now available. That is a cloud-based system with GPU in NVIDIA GPU that is now available. I have highlighted because it is a cloud-based system with highest power among the cloud-based systems. But the other top three are actually kind of mainframe computers, not available on cloud. I skipped this GPU hierarchy. I will just come to the last part. Parallelism. How do we exploit parallelism in machine learning? Just a brief overview of this. Okay. So see, most of the time we are, in fact, in all machine learning applications nowadays, we are working with neural network. Right? You will learn, in fact, in your third year or third year probably, right? AI and machine learning, most probably in third year. So you will learn about neural network. I'm just giving, because I'm not an expert, so I'm not going to tell you the details. It's just a description. We have a neural network here. We give an input, like this is a cat or this is a dog. We have certain parameters, okay? And neural network will output, because it has been trained earlier with several such images. So it is already trained, it will output a sitting dog, okay? Based on this function x and theta, where x is the input and theta is the parameter. Theta will be the parameters, okay? Based on that, it will output a sitting dog. That is what we expect from a neural network. But a neural network is actually divided into various layers like this. On this side, your left hand side, that is the input layer. On your right hand side, this is the output layer. And in between, there can be many such layers. Okay? And if you increase the number of layers, obviously your neural network will answer more accurately. Obviously based on data as well, input data. Lot of input data means more accurate response, and lot of parameters means more accurate response again. Okay. So we can increase number of layers, we can increase input data, we can increase parameters. Based on that, we will get accurate answer. So when we have such a layered structure like this, basically neural network like this with layer parameters theta 1, theta 2 and theta 3. Sorry, here we have theta 0, theta 1 and theta 2. Then each layer can be divided in such a way that many processors can work together. That is where we exploit parallelism. I just wanted to give this overview. Just to give you some sense of how the modern models work. See, we started in 2014, VGG16, a model, GNMT, this side is the parameters, right? BART, which is half a billion vector, BART model. You don't know about these models. Again, you will learn about these models. BART is again a neural network model which can work like GPT, ChatGPT. I am just saying that, but obviously it works with language. Probably, I hope you will learn about this. Then GPT-2, earlier version of GPT-4. ChatGPT uses a modern version of, in fact, another advanced version than compared to GPT-4. So GPT-2 is an earlier model. You see, almost close to 1 billion. Then Megatron, Turing NLG, GPT, Llama. Llama is more advanced model which is close to 100 billion parameters. GPT-3, close to 100 billion. So it is increasing. Day by day, the number of parameters are increasing. And GPT-4, that means when ChatGPT was first released, it used GPT-4. GPT-4 was trained on around 25,000 NVIDIA A100. A100 is an advanced GPU chip. A100, and took around 3 months when it was first trained. If we use just one single NVIDIA A100 on a high-powered server, GPT-4 training would take 172 years. So you can consider what is happening nowadays, right? So this is what I wanted to explain in today's discussion. So obviously, I told you that these layers can be parallelized, but there are different ways to parallelize. Like, say for example, the data can be divided into batches, and the batches can be sent to different neural networks, stored on different GPUs. So there are different ways. Again, I'm not going through this, just skipping all this. If you wish, you can obviously learn after you complete your artificial intelligence and machine learning course. Some papers are there how to parallelize. If you are interested, you can obviously learn from these papers. Again, not explaining this, skip, because no time. Okay? So, I come to the conclusion now. Uh, the other reason I skipped because some of the slides may be a little complicated for the students who just passed first year and second year. Right? I hope once you study artificial intelligence and machine learning, when you finish this course, then probably such type of discussion may be arranged by your college or by your teachers, faculty members. So coming to the conclusion, present days AI workloads are very much data intensive. They need to ingest a lot of data. They need to process a lot of data and output a lot of data. Here's a quote which says, as a result, what they need is an ability to store large amounts of data, to process large amounts of data, and to be able to throughput, exit, or output large amounts of data, and all of these done at large scale and at tremendous speed. This is also important, speed. However, there are many strategies to achieve a good solution. The best strategy depends on the model and underlying machine. So this is conclusion of the technical talk, but for students, the takeaway from today's discussion is that AI will eliminate mere coding jobs. Many of you dream for coding jobs, but possibly you will stay in the profession maybe for next 30, 35 years, I hope. Okay? So mere coding jobs will not be there. So if you focus, obviously coding is required. Coding is very much required. But if you focus only on coding, I tell in every induction program, every orientation program nowadays, if you only focus on coding, then it will be difficult to sustain in the profession. The need for writing efficient codes for AI, machine learning and other domains will increase. So, you must possess the essential skills to survive in this changed world, and you must focus on the core computer science subjects. The teachers, when they design the curriculum, they include operating system, they include architecture, they include communication, and sometimes you think, why do I need to study all these things? If I can do a good coding, company will hire us. But again, if you go through the last year's statistics, many of the dream companies, including Amazon, then other companies, Deloitte, etc., they are just firing the programmers who have learned only coding. So if you ignore the other subjects, then obviously it would be, you may get a job, but it will be difficult to stay in the profession for a very long time. You will always have to update your skills, and see, we are actually talking about lifelong learning nowadays. So lifelong learning is very important so that whenever you get something new, you can cope up. That is very important. So this is a takeaway for students today. Have a very good day. Thank you very much for listening to me.
Thank you, Professor Nandini Mukherjee ma'am, for this thought-provoking session on high-performance computing. As Alan Turing said, I propose to consider the question, can machines think? You highlighted how machines are evolved to think like humans, beginning as their machines, shaped by education and refined through experience. From the early stored program computers to IBM's Deep Blue defeating a world-class champion, we have traveled a lot. HPC is the driving force behind today's large AI models, with cloud infrastructure making this power more scalable and accessible than ever. Your insights truly illuminated HPC's critical role in shaping future. Let's give Professor Nandini Mukherjee Madam a warm round of applause. Thank you.
Before we move forward, it's our privilege to introduce the remaining eminent dignitaries who have joined us for this special occasion. We are honored to welcome Professor Devjani Mitra. She is currently a professor of Department of Electronics Engineering at IIT ISM Dhanbad, where she has been serving since 2010, with a total academic experience spanning over 30 years, including earlier roles as associate professor, assistant professor, and lecturer at IIT ISM and B.Tech Center. She holds a PhD in Electronics Engineering from IIT ISM Dhanbad, awarded in 2002 for her interdisciplinary research on sensor fusion strategies for robotic applications, recognized in international conferences and journals. She also completed her M.Tech by research in electronics engineering from IIT ISM Dhanbad in 1997, earning an excellent grade, and a B.Tech in electronics and communication engineering from BIT Sindri in 1990, graduating with distinction as the second topper in the university. Dr. Mitra has led and contributed to several funded research projects sponsored by organizations including DRDO, DSP, SERB, UGC, MOD, MHRD, and NTPC, covering areas such as wireless communication, cognitive radio, spectrum sensing, phonocardiogram signal analysis, and sensor-based measurement systems. Her research specializations include 5G technologies, machine learning, statistical signal processing, convex optimization, and intelligent control techniques, with application domains like cognitive radio networks, radar tracking, and radio environment mapping. She has successfully guided 11 PhD scholars with 2 ongoing and has been recognized with awards including the Young Scientist Fellowship from DST Government of India. Let us welcome all Professor Devjani Mitra with a generous round of applause. Now, we extend a warm and respectful welcome to Dr. Ranjini Menon. She is a scientific officer at the Variable Energy Cyclotron Center in Kolkata, India, a premier research institution under the Department of Atomic Energy. She has also served at the Indira Gandhi Center for Atomic Research, IGCAR. She has over 25 years of work experience in accelerator physics and applied research. She has an MSc in physics and a PhD from Durgapur University. Associated with the accelerator laboratory at the center, she has developed expertise in various plasma-based ion sources such as ECR ion source, RF ion source, etc. She also serves as the training coordinator at VECC, facilitating internship opportunities for college students. As a member of Public Awareness Cell of VECC, she conducts outreach programs in various universities and institutes. In addition to her scientific pursuits, Dr. Menon is a mountaineer and holds an A grade in the basic mountaineering course from the Nehru Institute of Mountaineering, Uttarpradesh. She has participated in several Himalayan treks and expeditions. As a passion, she pursues teaching and practicing meditation and breath works also. Let us welcome Dr. Ranjini Menon with heartfelt applause. Now, with great respect and admiration, we welcome Dr. Manjira Sena. She is a senior scientist at TCS Research India, working in the Data and Decision Intelligence Group, Kolkata. Prior to that, she was assistant professor at the Indian Institute of Technology, Kharagpur. Her research interests span natural language processing, artificial intelligence, and assistive technology. Dr. Sena is also passionate about gender equity and STEM. She was chair WIE IEEE Kharagpur section from 2020 to 2023 and has also chaired multiple tracks in Grace Hopper Celebration India from 2018 to 2024. She is a researcher in natural language processing whose work seamlessly bridges industry and academia. Her expertise ranges from tackling complex text mining challenges to exploring language comprehension and psycholinguistics, where she delves into how humans process and understand language. As an educator, she has taught courses in machine learning and natural language processing, inspiring students to engage deeply with this transformative technology. Her passion, however, extends far beyond the classroom and the lab. She is deeply dedicated to assistive and augmentative technologies, driven by a vision of making the world more inclusive through innovation. Beyond her research and development efforts, she also teaches a course that helps young engineering students understand feasibility and empowers them to design impactful assistive solutions. Though her research, teaching, and advocacy, she combines expertise and empathy, making a meaningful impact on that resonates both within her field and beyond. Let us welcome Dr. Ranjana Chana with a warm round of applause. We now move on to one of the most intellectually stimulating sessions of today's event, the panel discussion. The theme of our discussion is research ethics in the age of AI, a topic of great relevance and urgency in our contemporary world. Artificial intelligence is no longer an emerging trend, it's already transforming the way we live, work, and make decisions. However, with such advancements come pressing ethical concerns, including algorithmic bias, transparency, data privacy, informed consent, and accountability. As aspiring technologists, researchers, and thought leaders, we are not only expected to innovate, but also to reflect on the social impact and moral responsibility that innovation demands. Today's panel brings together thought leaders from science, engineering, industry who will share their perspectives, experiences, and visions to help us better navigate this complex but essential field. May we now request our honorable panelists to kindly come forward and take their seats on the stage as we begin this insightful panel discussion. We also take this opportunity to invite our esteemed moderator, Professor Sri Sinha Chaudhary, to lead and guide the conversation.
Good afternoon, participants. I hope we are audible without a mic. Yes. Okay. If we are audible, then we do not need a mic. Yes, ma'am. We have been listening to a lecture that is very much relevant in today's world because whatever Nomini Madam had talked about just a few minutes ago is very relevant in today's world because we are employing AI tools in practically everywhere. Uh, in some places, AI tools are embedding our lives unknowingly, we are using them unknowingly, and in some places, we are making a choice about using these tools. And some of these have penetrated into the classroom teaching and learning as well. So, as Madam was asking you students that how many of you use the AI tools? They have been there for the last few years, and I just want to know that how many of you have really used the tools in preparing your reports. Okay, only a few are brave enough to acknowledge. I don't know, maybe some of the others may have used, but they are not willing to show, and some have not used at all. That I am ready to believe. Initially, I even did not use it, but sometimes these AI assisted tools, they help us save time, and they help us with some tedious jobs like arranging, streamlining whatever we are thinking of, whatever we have to show, whatever we have to report. So I may have thought of different points, I may have written them down, but using these tools, they help us in streamlining the ideas into a presentable format. But of course, if I use only the tools and I do not put my idea into them, then it does not make a meaningful approach, because I don't know what I am going to talk about, what I am going to present. So my presentation should be in my control. It should be having my staff, but the presentation should be good because of these tools. So the topic, the research ethics in the age of AI. We have to balance the innovations and the responsibilities. Responsibilities come, higher responsibilities come when we have more power in making an impact. So the key things are that we should be understanding how to use the AI tools, and we should also be aware where we shouldn't be using them. Now I would like to ask the panelists about how research is encouraged in the different institutions from where they are coming. So first I go to Dr. Debjani Madam, professor. She is a professor at a very renowned national institute, and whenever students are working on different projects, we always encourage them to write a paper if the results that they are generating as a part of the experiments, they are good, they are promising, and they are helpful in presenting a novel idea. So madam, how much of importance it is that students should be publishing?
Okay, in the context of the theme that we have been talking on this panel, that is research ethics in the age of AI. So there are actually just three aspects of it. The first word is research, the second word is ethics, and the third word is AI. So the whole subject matter is basically research. So what is basically a research? And most of the research these days, there, so when we try to link, I would just like to add one important point over here, that by research, what are we meaning? In today's world, research is basically of two types, where there are research institutes like CSIR, labs, etc. that primarily they are research organizations. And also we have academic institutes where the students, our research scholars, are carrying out the research along with under the mentorship of professors. But recently, the moment we want to add the word ethics to it, and your publication part is also coming linked with it, I would just like to add a very small point, because you are all the next generation researchers. Because these days, the research is associated with the PhD degree, if I am correct. And the major motivation of the researcher is to get the degree. It may look a little bit crude, but that is the fact of life. So, and it is not only in our country, it's a worldwide trend. So the moment we want to quantify research, so it is usually done through the publications. And there are certain, as far as ethics goes, so a lot of things are coming into the picture. So here, one major point that has come, whether they use AI tools or not. AI tools are definitely, as ma'am said, Sherry said, that they are definitely going to reduce our time and effort. But these are all LLM models, mostly they are very good at summarizing. So say you want to study a research paper, so they give you a very good summary. So definitely it's going to be saving your time and effort. But actually speaking, where we are losing in the world of AI is the knowledge. So the knowledge is actually, the learning is happening only for the machine. It has already happened, it has already learned. So it is basically when we are just taking down some notes and also it is not actually increasing our knowledge. So whenever we are understanding or whenever research has to be validated, and then whenever we are doing a research, whatever PhD level work, I think AI has reached the level that it can act as a very good PhD student. It can do a lot of the coding, etc. Most of the things that were done by the students and all. It's very good at it. So it's another good, a very good PhD level researcher. So now, what is the role of this? How much of AI do we use? Now, as far as AI is concerned, definitely HPC platform is the one where it is actually going to be implemented for, depending on the type of data set, etc. But here, is the AI accessible uniformly to all? Because the moment it is a tool, you can imagine in a day, in a century or maybe many years ago, when we did not have internet. And there was internet facility in some other part of the world. They were quite advanced. So, very at the same level. So, it's naturally, if AI has come and we are competing for the part of publications, we are competing at the global level, almost all the countries are working. So, definitely AI has to be accessible equally to all the researchers. And then, so that is very important. There, if we are missing out, so we should be having a separate type of training where students, because students at UG student, PG student, even PhD students, they are very nice. So they have a tendency of putting anything into Google and then trying to make some mistake. So usually there is no dearth of materials in the internet, but how much of the learning is happening? So the learning is actually not happening for the students. Earlier a PhD or a research degree is associated with knowledge. So that is not happening. For most of the cases, I think the statistics is 10 to 20% of our PhDs are actually being actually fruitful. Most of the cases, I think we regularly do faculty interviews and all. We get a lot of applications, all good PhDs, good publications. But then most of them we are not able to select as teachers. Because when we are trying to select them as teachers, PhD is just a training, the research is also a training. Then we see that that knowledge has not been transferred to their 5 years of work. Because mostly they are driving towards the, what we call the business. So this is one part. I'll not call it pure ethics or something, but definitely it is related to ethics. So when you are doing, definitely your motivating factor should not be only to get the degree, but it also should be to learn. It's a training. You learn the various types of software. You learn, how to do research, how to understand. You should be able to, your soft skills are very important. It's just if you type something, AI is going to give you a lot of things. But then are you able to interpret that? Are you able to further work on it? So it is going to give you a sort of things, what are the things to study. Maybe there it can help. It can be a good teacher, a good mentor sort of a thing. So that's not going to get tired. Okay, so every time you type something, you'll get some help. So use it as a mentor, use it as a teacher, so that you know what to start further do. But then at the end of the day, you have to understand that it is not a black box. Most of the AI tools, there are two ways of using it. Most of our students, as ma'am was saying, they want a project in AI, ML, AI, ML. The moment I say, okay, you do this problem, how many days you will take to do it? So, 7 दिन में कर देंगे. I'll do it in 7 days. So I said, if something can be done in 7 days, so it can be done by anybody in 7 days. So do you think that actually you learn? Because see, one command, let us say support vector machine, it's a very popular machine learning algorithm. You just type SVM in MATLAB, put some argument, put some data set, etc., etc., it will give you. But if you try to actually understand what is SVM, it will take months to actually understand the derivation, the optimization and all. So what is the point of doing that? Even somebody without a degree, even a class 12 student or a class 10 student, he can also type SVM and put some command in it. So that is not, so that depends in which level you are trying to work. So if you are working on a research, so research means you have to investigate, you have to experiment. So PhD, what does PhD stand for? What does PhD stand for? Yes? Doctorate of Philosophy. It is no subject or anything. Okay, we call MSc in physics or this and BA in the history or something like that. Here we are not giving any subject. So it's the only subject is of philosophy. Philosopher is somebody who can think. So you should be able to think. That is the only quality that a human brain has. That's why Turing asked, started it, can machines think? So human beings can think. So we should not be losing that capability. So unless you are able to think what is happening, and then you get a command, you use the tools. There's no point when somebody has to write a code of SVM again. When somebody is already available in the form of a MATLAB function or some other Python function or something like that. So, okay, but at least when you are using it, you should be, you're working on a problem, you should have the knowledge, then you need mathematics, statistics, other optimization tools. So that is where your training goes. So there is where the ethics should be there. So I'm going to learn this not as a black box, but also I should be taking this.
Nandini madam, let me just change this question to you a little bit. Since we would like to discuss on the how research is encouraged in different organizations, and I would like you to explain it in from the angle of how accreditation plays a big role when we are encouraging students to go for to do research when they are doing their final year projects and also their master's thesis.
Yeah, so I would like to focus on this question only, how research is encouraged in our institution and accreditation also. So in our institution, actually we encourage the students starting from their undergraduate studies. The project is oriented in such a way that there is a little bit of research component. So as Madam said, research means some kind of innovation. What you can add to the world of knowledge. That is the research. If you just have some data and run SBM and produce some result, that is not exactly research. We do not tell that is a, do not call it research. But obviously, as undergraduate research student, sometimes you should be acquainted with this kind of tools. Maybe when you write a Python program, use Python library to run machine learning algorithms. Those things obviously a learning process. But when we talk about research, the question is, what do you add to the world of knowledge? What is your innovation, some novelty? At the undergraduate level, we do not think there will be a lot of novelties, but a little bit. Maybe some experiments, new type of experiments, something like that we expect. Not just application development, but something which the students should learn how to do the research and then producing a report also. And at the master's level, obviously, we can always consider that the student should be able to do something. 1 year, the student should be able to spend on research alone. Many of you perhaps know that 1 year is for dissertation only. Before that, usually in our earlier curriculum, we had 1 semester when the students used to spend studying the different types of literature in a particular domain. So we used to call it term paper leading to a thesis. So I think probably some of you may remember term paper leading to a thesis. So basically the thing is you need to study the literature. So that is one important requirement for doing research. That means you need to have survey the literature in a particular domain when you want to contribute something. Because see, if you want to contribute something, then obviously you will have to study what is there already. If I already know, if something is already there, there is no point of discovering the same thing again and again, right? So this is important. Studying the literature in a particular domain, and then you go forward for doing something new, which can be published as a paper. So that is at the M.Tech level, and obviously PhD, Madam mentioned about PhD. I am not going to focus on that. Shelly madam asked me about accreditation. So see, when we go for any kind of accreditation, NBA or NAM, or even when we participate for any ranking, research is very important. And there also undergraduate research. That means we need to uh, mention how many undergraduate papers have been published. That means whether when we do any research, the faculty members particularly, whether we could involve undergraduate students as well. That means this is like growing interest of the students in research. So that is whenever we try to go for any kind of ranking system, this is one of the requirement. And so obviously we do not expect undergraduate students to who will be able to do a lot of things, lot of innovative things, but uh, faculty members or master's degree students or PhD scholars, they are doing the research, and it is always a good practice in our university at least to engage the undergraduate students with the PhD scholars, research scholars, or faculty members. So that is the way I also think, and many of our colleagues also do the same thing. Involve undergraduate students with the research of faculty members or with the research of doctoral students or master's degree students. So the students, undergraduate students, they learn a lot of things. And when we talk about, and in fact that is the point why accreditation bodies, they ask for UG students papers. So that is the reason that they actually ask for what is the contribution of the undergraduate students in this particular, in all these publications made by the department. So this is something which we follow.
Thank you. Yes, Dr. Menon. So coming from a research organization, how is it seen over there?
Yeah, so I'm a little bit odd man out or odd woman out. They are all academic people and excellent speakers. And thank you so much for the opportunity, first of all. So, as she told, I'm coming from an R&D unit. So, DAE has 6 R&D units. One is BRC, VCC, and 4 others are there. So, and one of the main mandate of DAE is to uplift the technological strength of the country by research. So that is there in the mandate of DA itself. And all other mandates, so there are different mandates for DA. You know about Department of Atomic Energy, I think so. Yeah. So otherwise by end of this panel discussion, at least you should know. So Department of Atomic Energy has several other mandates. One is national security and then energy security. It works for, you have seen that few moments the power has gone and how it troubles us. So imagine about the power of the country if it goes for a day or two, what will happen? And you can't ask this to another country. You cannot depend on some other country for getting the power. They can put a lot of conditions. And you will become totally helpless if you are starting asking energy from another country. So it is very important to secure the energy part. That is a mandate of DAE. And since self-reliance is the key here, research is very, very important. So we deal with, you may be knowing that nuclear reactors for energy production, and all this high-end research is being done for making new reactors. A lot of new developments are done, and many of the reactors are indigenized. This all happened because of high-end research. And not only these two mandates, then also for the food security. These are all surprises. When I joined DA also, it was a surprise for me that DA works towards the food security, water security, and also health security. Health security because a lot of cancer research or cancer diagnosis therapies can be done by radiation technology. So DA put a lot of effort in that research. So main research organizations on the cancer radiation therapies and all is done by DA, and also for agriculture and for producing new crops and also for processing. So a lot of radiation technology is used. So for all these things, we have to develop your own technology for that. Research is, it's like research is our bread and butter. So we don't keep it aside. So it's a part of our. So we have one societal applications very near to Kolkata. In South Kolkata, we have a medical cyclotron that is producing radioisotope for cancer diagnostics basically. So there are also a lot of R&D works are done. So some of the isotopes are produced first time in the country or first time in this part of the world. So a lot of research is being done, and it is very diverse, as I told, from crop to radiation, even how to handle the fuel, reactor materials, lot of material science research also happens. So it is a diverse field.
Now, Dr. Sinha. So, you are representing industry in this panel, and so we would like to know your views.
Good afternoon, and thank you students for the generous introduction. So, in industry, actually in industrial perspective, when we generally think about research or the common perspective is that these are mostly short-term goal-oriented or product-oriented. But actually it is not the case. Uh, for many industrial labs, the research is not only focusing on, say, artificial intelligence or what we commonly think of as technology. They are also contributing to sectors such as food and agriculture, which we say, if I say I work in TCS, we generally do not connect that to, say, food or agricultural perspective. But how these two are connected, because now these fields also they leverages lots of technologies like remote sensing, artificial intelligence, and different sensors. So the industrial research comes within that perspective. And in industry, it also understands that for a path-breaking product development, say for example, as the Mundiri madam has mentioned about Deep Blue or IBM's Watson, or more recent Google's model for beating the game of Go. So all these are parts of outcomes of industrial research. But why they were done? Is it because that they wanted to develop one specific thing, or to beat a, say, chess grandmaster, or to win the games of Jeopardy, or to beat a Go grandmaster? No. The reason is that they all leverage the path-breaking research components at their time for reinforcement learning. So generally there are decades of research from industry behind this, and you will see that even today's ChatGPT, that is products of decades of research in neural networks, transformers, reinforcement learning. So in industrial research settings also it is recognized that to make a truly new record-setting output, you need to invest behind research and foundational research. So yes, from industrial cases, we have a lot of motivation for research. And one thing I would like to mention that nowadays, from conferences, from industry and academia, there are also focus on the negative results of the research outputs. There are lots of specified venues and workshops which are getting organized to discuss about which is not going to solve the problem at hand. So when we talk about research, we do not only think about what the success is, but if I fail, why am I failing, and how we can take motivation from that and to build a better model. Thank you.
Thank you. This is one perspective we don't often discuss, but I feel that when I am encouraging a doctoral student to work for his or her thesis, I always ask that student to report the results that do not come out to be well also, because that contributes to the overall study. I will be starting from that end because the importance of publishing for academic institutions, publishing is important, as both Professor Mitra and Professor Mukherjee have already mentioned. So from your angle, how much importance is given to publications, not just research, but also how much importance is given to the publications also?
So publication is very important, right? Not only for the appraisers, but from an industrial perspective, the industry also wants to make it smart in the domain. That's say in artificial intelligence, how many top tier publications we have from our labs, and sometimes that is actually directly tied to the kind of financial investment they can draw in, particularly for startups and things like that. And actually, in the industrial cases, the pressure for publication is more because it is always expected that you publish in the top venues, because otherwise, like the encouragement or the grants, so they are directly tied to the kind of top tier publications that you are doing. So it is quite an important facet these days, and we see that lots of industries, they kind of invest very largely behind us, even having good researchers who will bring on board lots of top tier publications and will motivate others. So that is the reason lots of industries actually sponsor their employees to pursue PhD from different academic institutions. So the whole idea is that to train people to do good research, good publication, so it is beneficial in the long run for outcomes of the board.
Yes, Dr. Meena.
Yeah, so publications, everybody knows that publication is very important, the part of, it's a part of the research. So it also checks the quality of the research as well as it can be used for sharing the knowledge. So for those who are doing basic science in BAE, so it's a kind of mandatory that they keep counting how many publications they have. But those who are working with the technology or those who are implementing that application oriented, so it may not be very necessary to have a peer review journals for us. For example, I work with the national facility, cyclotron charge particle accelerator is a national facility. Throughout the year we are doing R&D, but many times it may not be conducive to translate all the work into a research paper. But we have a documentation process, like we make internal reports, and also we have annual reports and newsletters are there. It is highly appreciated to put all this because it is necessary to transfer the knowledge for the next generation, and as well as sometimes for us to look back what we have done. So it is necessary, but at the same time, for those who are working in this technology-oriented things, national facilities, we don't really count the publications. In fact, what Madam was saying earlier, even there are some directors of some very premier research institutes, they don't even have a PhD degree. So they are full-time, they are doing R&D only.
So we find out that for educational institutes, research and publication are very important, but research is obviously important for the R&D industry also. But they may or may not be focusing as much on publications like maybe we are doing. That is my general idea. Anyone from the audience would like to add anything to this? If you have any other idea than what we have already discussed.
May I just say something?
Yes.
Sorry, I'm talking too much probably. But anyway, just one point I wanted to make, because two persons who are working in the government sector and the industry, and we three are from academics. There is a lacuna in the research in our country compared to other developed countries. Basically, in the developed countries, the idea is born in the academia. And then, because academia focuses on giving birth to the ideas, concepts, and then publish, that idea goes to the industries, and then industries convert that idea to products, which we do not have. That's the unfortunate thing. I mean, never, very, I mean, last time we found that industry is getting a, connecting a bridge with the academic persons. So that is one problem in our, in doing research in our country. I thought that I should mention this here. Yes.
In that I have to say something, ma'am. Actually, in that our country, the problem is that the industry is not all supposed to come to the academic. Actually, they are supposed to not collaborate with but to the academic persons. They are thinking that they are academicians. We don't go to them. But in the outside world, that is actually developed country, they are giving the problem to the faculty members, the universities. Say they are thinking on that particular problem and they give the solutions to them. They are believing on them. But here in our country, they are not believing. That is the main issue. So we are giving the solutions, but they are not accepting sometimes and they do not believe us also. That is the belief system problem is there.
If we start discussing on this part, then we can have another panel discussion sometimes next, because I also have a lot of things to say to this from my experience. Now, moving on to the next part, that is the influence of AI tools on publishing. Now we have heard that when we are into research, publishing is a very important part of it, because when we are generating new results, useful results, it should be recorded, reported, so that the next generation scholars who will be coming into this, taking up this problem and pursuing it, they will be having something to move forward with and not repeat whatever already has been done. That is why publishing is very, very important. Now we will be discussing about the use of AI tools in publishing, how we are seeing it, how we are using it, or what are the problems we are facing due to this. Yes, ma'am.
Once again, as a main dissemination of the research is publications, and there are, as you said, that there are doubts about the industry, and it's not exactly doubt. What I feel is that they do not know what academicians are doing, and vice versa. Academicians also do not know what the industry is actually, because they have a short-term goal of a certain product or certain technology, because they have to do, they have their commercial model also, which they have to sustain. So there, I think because of this silo kind of thing, that this has to break, and definitely once the academicians, we are as professors, what happens is that we are very good at analysis and mathematics and this, that. So normally sometimes that may not be exactly required in industry. So somewhere down the line, that balance has to be there. They do, I talked about especially TCS, research innovation and all. So they told me once I went there, my student was doing some research. So they said, no, we do look into the papers, and the moment we find something, we try to implement them first, because you people have already done it, you have studied. They don't get so much time to study the entire thing. So definitely a good academic paper which is relevant to the industry. So that is very important. That's what I was trying to say, that whenever we are trying to select a research topic, it should be relevant to the industry. It should be something that deliverable. Somewhere we should be making some advancement or some innovation or contribution that is actually, we can say that it is going to be useful. So that will solve many of the problems. And coming to the AI tools, and there's the issue of plagiarism. I think we Indians are very bad at understanding the issue of plagiarism. So I think our students should be made aware, because the moment you go for your masters and all in good universities abroad and all, so there you will find they are very, very strict about plagiarism. So we don't think plagiarism, then false reporting, then these days they call something some salami slicing or something, where the same research they break into parts and then communicate to the journals and all. So these kind of things, AI can be misused also, but then these kind of things should, that's not going to help in any way. It may be increasing your number of publications from 1, it can become 3, but it's actually not going to help you in knowledge generation. At the end of the day, so when you are going whether in industry or all, people actually look for something concrete.
Yes, madam, I'll be repeating the same question to you.
Okay. Regarding AI tools in publishing, actually there are two sides. One is for your convenience, and the other one is probably, as Madam said, plagiarism, etc. For your convenience, I can say that for doing research, AI tools help you a lot when you try to find something. Nowadays, particularly, obviously, in our days of research, I mean, when internet just started, so we could search something, and whenever my students used to search something, they could never find anything, and they used to come to me and tell me, "Madam, we could not find anything on this topic." So I used to sit and give some praises, and then I used to find very relevant papers very quickly. So that was actually, have you heard about prompt engineering nowadays? So my prompt engineering was, that time we used to do this. But what I'm trying to say, nowadays, this has become very advanced. When you search anything, search for anything, there are AI tools now. One AI tool, Gemini particularly, is embedded with Google search. And whenever you search anything, you will get very quick results in summary form. And then it is your responsibility to get the papers from different areas. In fact, Gemini sometimes gives the reference as well. So Gemini is there, ChatGPT, obviously ChatGPT solves many things where you can whenever you ask, ChatGPT will give you the result. So this type of tools, Gemini or GPT, they will provide you the results required by you in a summary form. So that is the convenience side. The other thing which I often advise my students to use AI tools, that is called paraphrasing. Because the language is maybe 5 years back you could think that I have studied in a Bengali medium, so that is a problem. We also thought like that. But now it is not a problem at all. If you can write a sentence in English, right or wrong, the paraphrasing tool is there which will help you to construct the sentence in its correct form. So then it is there. Spell checker, paraphrasing obviously applies some AI techniques, so it's there. So I think this type of tools may actually support the students for writing papers for publication. But there is an analytical side also, which I think we will talk about that later, next year.
We use this authenticate for plagiarism and also for AI content, generated content detection. So yesterday I was talking to our librarian. Library has that purchased version, so we use from the library. I was just talking to him since I.
The question do you use AI tools in any way? Like
To use to generate the content.
In our educational institutions. So from that angle, I was asking that whether AI tools is used in creating your reports also or not.
Actually, I used to just do a time pass and asking questions in the cloud AI and all this ChatGPT, asking questions on my field, plasma physics field, and every time they give a wrong answer. So I used to argue with that, and ChatGPT apologies also. But it's a quick learner, very good student.
Yes.
So they are coming. So all this domain specific knowledge is not their skill. So as Madam suggested, the core idea should always come from you. So they can only correct the grammar and all those things. Why I was telling that example yesterday's evening, librarian, I was just talking about this. So he was talking about a AI tool that is purchased by a nearby school to check the AI content in homeworks given to the students. So it's something they have purchased. So I just came home and I opened Insta and lot of advertisements, no, related to that. Yes, to cover up the AI content, AI detection proof. Uh, New tools have come up. So quick and it's coming in a big way. So we can't stop it. So it is our skill. We have to discreet ourselves where how far we will be using. So recently I was listening to one lecture by IAEA, International Atomic Energy Agency director. So he was saying that we are now making a new modular reactors. So now the reactors are big facilities far away in some desert or somewhere or near the sea. But now in cities we will have modular reactors. Throughout the world the research is happening. So we can have small points of energy production. So US department gets lot of demand from this modular reactor to be implemented faster. And the majority of the requirement comes from AI companies. So can you imagine, so in such a big way they are coming up. So it should be our skill. And as Madam told that everybody wants to do only in AI. As I am a training coordinator, students comes to me from various colleges and I discuss with them what they want to do. They want to do in AI. NIT Rourkela, one student came, she's a physics student, she wants to do machine learning. So nuclear physics, what you will do with machine learning, but ultimately she collaborated with one scientist in our place and then they developed one AI tool for finding out the half-life of exotic nucleus. So there are good things also happening. So it's up to us discrete what we are, how far we use it. Yes, Dr. Sinha. How do you use AI tools in your organization?
That's for sure because now we do not have, we are kind of dependent on the artificial intelligence tools, but also at the same time we do the work in a restricted environment to ensure that these tools are not used for, even something like copying codes or generating malicious content. So now coming to the larger question of use of artificial intelligence tools for research and publications. So publication or research has many aspects, like writing the paper comes later. The first is that how do you make a problem statement, identify a problem statement, and then how do you come up with the models, in the computational cases, the mathematical models to solve the problem statement. So nowadays, actually, if you go to ChatGPT, Copilot or Gemini and you ask that I want to write a paper on say topic X with a complex mathematical model, can you give me an outline? You write what is the problem statement, you give me a mathematical model and it does. What it also does is that it also asks you that shall I write it in the format of say a Newdip's paper or an ACL paper. So it is also ready to write the paper for you. But the problem is that if you do not have understanding of the fundamental concept, then how do you know the mathematical model that it is proposing? It actually does make sense or not. So from my perspective, if I want to generate a model for the new policy optimization, I can ask Gemini that what is the state of the art. But the result that it gives, I need this understanding in the reinforcement learning and the mathematics to actually evaluate that whether it makes sense. And also even before that, how do I know that what is the right question to ask? As Madam said that, if 2% square is the same system, based on the experience, based on what kind of keywords you should look for, the results vastly differs. And that experience comes only from the fundamental understanding. Later on that, you use the artificial intelligence tools to maybe polish your research a bit, maybe enhance the grammar a bit. That is not an issue because nowadays lots of discussions are going on that as we cannot evade these artificial intelligence tools in publications, so shall there be a co-authorship for ChatGPT as well, and lots of conferences are asking for explicit declaration that how you have used the generative artificial intelligence tools. So coming to that, actually, there was a recent news that into one of the colleges, the students said that professors, they use the GenAI tools for making notes, and they asked us not to utilize them, so we want the tuition money back. So the problem in this kind of arguments are that when a teacher is preparing a note, or say if I am preparing a lecture for tomorrow or a presentation, I am going to take help of GPT or something else, maybe to ask that what are the state of the art. Or I know that how do I ask it questions repetitively to understand more and more to what the community is thinking. But how do I know that to evaluate the state of the art or to ask these questions from the hard work that I have put into in my student test and after that to learn that concept. So, but if you are as a student taking help from GPT from the very beginning, you are never going to learn it. And the problem is that if you are not going to learn, research or even coding, as Madam said, like mere coding will not exist. So those are not actually just calling and API interfaces. If you want to be a successful coder, you need to understand how to make my code efficient, where to call certain APIs. It's not that we have the large language models, so every problem has to be solved by that. So fundamental understanding is very important, and of course you can utilize the artificial intelligence tools, because see, like we used to call brain is a muscle, but now with the research in the neuroplasticity of the brain, we have understood that this cognitive atrophy, or what is called the brain rust nowadays, or the over reliance on these tools, are very real. So we have to be careful. We want to publish good research, we want to write a nice paper, but it should be the fundamental understanding of us and the knowledge, like we should learn in the process, not the other way around. So the other day, one of my colleagues told me that we are writing so many things, but who is going to read it? So I said, GPT is already reading it. So GPT is learning, but we should need to learn as well. So for that, use artificial intelligence, but with the resilience that at the end of the day, it should be we who should be benefited. Thank you.
Coming back to the last round, coming to the last round, that is the ethical angle. So some of the ethical angle have already been mentioned. So I will ask the panelists if they want to add to this part.
Yes, I just mentioned the advantages, but there are some ethical angles. Some have actually been covered by some of the panelists, but I just want to mention one thing, which is called AI hallucination. I am not sure whether you know about this, you heard about this. AI hallucination means all these models, they are being trained. How are they being trained? From some data which are available on the internet. Right, so Manjira has already mentioned that sometimes we need to ask the correct thing also, because these models, they are being trained with right as well as wrong data. So in some cases, the AI model, say for example, it can respond that that France is actually capital of Germany. If you ask AI hallucination to Gemini, Gemini will give such type of examples. So I just want to tell, because we are talking about research, so I just want to give an example what happened to one of my students. The student did, master's degree student, the student did his own research, there was no problem, he did everything on his own, no guidance from AI tools, no guidance from nothing. And even he wrote the paper as well. But then he was asked to add the literature survey section. So he added the literature survey section with lot of references. And then I gave the paper to my doctor PhD student. When he was checking the paper, he found all those references are not related to computer science at all. Some of the references are related to geology, some of the references are related to other fields, but not computer science. So what he did, he actually asked GPT to give some references. Maybe he asked some questions or he gave some statements to GPT. Whatever was there, GPT picked up some papers not from computer science domain. Forget about his own domain. He was doing research in social network analysis. So not even related to social network analysis. GPT brought all these papers from geology. Okay, so it was an older model of GPT, obviously. Now GPT is more, much better than that model. But what I'm trying to say that you, as Manjita said, you need to have fundamental understanding about the fundamentals. You need to understand. Okay, and you need to actually, you cannot ever depend only on AI tools. You can get some support from AI tools, but not entirely dependent on the AI tools. If you understand, then whatever AI, artificial intelligence tools are saying to you, you will be able to judge whether it is correct or wrong. And then incorporate the basics of those things, or you can take help in whatever way you want. But obviously, you must avoid plagiarism, because nowadays, when you send the paper, as Madam said, there are many tools like Authenticate, which can actually find whether the plagiarism, whether there is any AI generated text. And if the tool Authenticate finds that there is any AI generated text, your paper will be rejected. So remember this, always take help, but do not ask the tools to write the papers or to do something which is not ethical. Thank you.
I'll just add one small point. I think it's already not in academic research immediately, but I think in other areas, especially with medical data and all, already such research organization must have an ethics committee wherever AI is being used for decision making, because depending on the bias of the data set, sometimes there is a bias of the data set, the severe bias. For example, they say if you type image of a school girl and image of a school boy, so school boy they will get proper school uniform boys photos, but school girl they will not get because of other reasons we all know. So because the internet is full of such material, so they have learned it something else. So this is a severe bias. Medical data, I think, where human beings are directly involved, maybe in our engineering research it's not so, but wherever medical data is involved, there are serious issues. I think all such organizations have a proper ethics committee, because there are some things which cannot take part in decision making, like empathy. So when we say we make a recommendation to our students, so we know many things. So everything cannot become a mathematical model. So we need a human ethics committee, which is a part of any, especially depending on the type of database.
Yeah. We also have that. So HPNMO Mubaba National Institute, that is the research institute which issues award degrees to the students. So they have strictly follow the UGC guidelines for these ethics.
Okay, so regarding the ethics part, I want to focus on three aspects, because often when we discuss this, we think that these are predicting this, what will happen, just one more back to publication kind of thing. But these are not. So first is the amplification of bias. So as we know, what these large language models, because when we say about generative artificial intelligence, we talk about GPT or Gemini or Copilot or similar things. So what data trained on? Vast amount of data, but vast amount of digitally accessible data. That means, say for example, those languages we do not have any written representation or digital representation. They are out of the training by default. But languages are also representative of people and communities. So that means GPT or similar things, they do not have knowledge about entirely, entire communities as a whole, or cultures as a whole, or perspective as a whole. So as a result, when we are asking something, they are producing results which are biased towards the dominant side. And we are utilizing again these blindly to generate more content. And while it is giving us the content, it is also learning from the content as well. So what is happening? The bias is getting amplified as well. So that's why we see lots of stereotypical results from even from like GPT, Grok or whatever that you take. So amplification of bias is a very important concept. Because as madam said, in medical cases, what used to happen that lots of medical researches used to be only done on say like white male cardiological diseases. So when they were applied the results on say different kinds of population, ethnicity, even gender, they did not produce the result that was expected. And it was not even recognized that why we are not able to succeed unless we until we look into the data. Second part is the what we often do not talk about is the impact on the environment and the climate. So you may have seen in the news that Sam Altman said because people are using the niceties like please and thank you, there are millions of dollars spent in this additional computation in the GDP. But these are not only millions of dollars, that every computation that we ask GPT or similar models, they also have a huge climatic impact. And actually where the data centers are, the people who live surrounding them, they are raising concerns that it is becoming destructive for the environment. That's why lots of researches are being going on the alternative models, small language models. Not only because they are easy to deploy, but because of their climatic impact as well. And we can only do this kind of research when we have the understanding of what we require. And the third thing is that how these have the real world implications. See, when we are designing a new model, when we are publishing a research, it is not only that it is on the paper only. Lots of these things, they are done with the objective of getting translated into real-to-world settings. Now think that as Dr. Lenin was giving example that modular reactors. So if tomorrow I write a paper with GPT on the modular reactors and I give a model and that is getting implemented because lots of reviews are also these days done by GPT as well. So now these are, and if the model is even a slightly off, so it will have a huge destructive impact on the cities and mankind as well. So these are the aspects that we need to think about when we talk about the ethics of generative artificial intelligence.
We come to the end of the panel discussion. Anyone from the audience would like to say anything before I sum up? Okay, so if not, then let me summarize that yes, the AI tools have made our lives very easy, especially in the field of research and publication. But if we do not understand the fundamentals of the things that we want to work with the topics that we want to work with, then it will not be of any advantage to us. It may rather backfire because we cannot always depend on the results that these AI tools come up for us. The AI tools themselves are in the learning process, so it may be something I am asking which nobody has asked it before, nobody has fed the data regarding that to it before, and so it will not be able to come up with the correct results. So I first have to understand whatever I am learning and whatever I want to work with, and only then should I go for using these tools, because otherwise the whole process of using these tools for the benefit of my better representation or whatever I want to report will not at all be a good idea. And since there are many AI detection tools being available in the market also, so in many cases where these are very critical, whatever I am coming up with will be checked by these tools to find out whether I have used any AI tools or not. And there should be declaration for the journal papers also, just like for the reviewers, the declaration comes that whether I am using any AI tool to review papers or not. So for the authors, it should also be coming in all the publishing houses, and wherever I am supposed to contribute in a very critical topic, on a very critical theme, these things should be made mandatory to have the declarations in place. So students, do use AI tools, because they will be everywhere, and you will see that your peers might be getting ahead of you by using these tools, but then do use them in a responsible manner. Oh, thank you.
I am midway in my PhD journey. So suppose I am writing a paragraph in a paper, and I feel like it can be better. So Grammarly is there. So is it possible to use the Grammarly, and I give a statement like I have used Grammarly. So is there any chance of getting the AI content detection?
Grammarly is rephrasing. It just rephrases whatever I have already wrote down. It's not generative.
But it became AI content, madam.
It has been taught to understand the grammar of the English language. So if I am very good at my English language presentation, then you will find that the mistakes shown by Grammarly are very, very less. Only if I am not very good at my grammar, then the number of mistakes will be shown to be more. It is possible to write without Grammarly showing any faults.
Yes, it is possible.
So we end this session.
To mark the formal To mark the formal conclusion of this inspiring event, we now invite the Chair of IEEE Student Branch Affinity Group DCRIC, Pratiksha Dalal, and Vice Chair Upasana Dhoot to deliver the vote of thanks. Good afternoon, everyone. On behalf of the organizing team, we extend our heartfelt thanks to our respected dignitaries, faculty members, and all attendees for making the inauguration of the IEEE Women in Engineering Student Branch Affinity Group at PCIC a memorable one. A special thanks to our Principal Sir, Chief Advisor Sir, HOD Sir, faculty coordinators, and the IEEE team for their constant support and management. To our speakers and guests, your words have truly inspired us to dream bigger and lead with purpose. Gratitude to the volunteers and organizers for their dedicated efforts behind the scenes and to every participant for your enthusiastic presence. This is just the beginning. Together, let's make Women in Engineering chapter at BCRC a platform for growth, leadership, and empowerment. Thank you.
তুমি এখান থেকেই করে দাও না
With this, we come to the formal conclusion of the inauguration ceremony of the IT series, Women in Engineering Student Grant Affinity Group PCRC. On behalf of the entire organizing committee, we extend our heartfelt gratitude to all the dignitaries, invited guests, faculty members, and students and the volunteers who have made today's event meaningful and memorable. Your presence and participation has added immense value, and we look forward to continuing this journey of empowerment, innovation, and collaboration. Thank you. A quick announcement for all student participants. Refreshments have been arranged outside the hall. We kindly request everyone not to rush. Please maintain discipline, form a queue, and follow the instructions of our volunteer. Thank you. Participants, please don't rush and stay here. Don't go outside right now. Please be seated.
అన్నీ అన్నీ মুখে ছড়ে যেত এই এই তোরা এদিকে এদিকে ফাঁকা কিছু করার নেই তো স্টুডেন্টরা ম্যাডামের সামনে দাঁড়িয়ে যাবে লাইন করে স্টুডেন্টরা ম্যাডামের সামনে দাঁড়িয়ে ঠিক আছে ঠিক আছে এদিকে সবাই হ্যাঁ পুরাম নিয়ে গেল দুটো দিয়ে দিয়েছে এটা বন্ধ করে দিলে যাই না তো পুরোরামেরটা নিয়েছে তোমারটা হয়নি তো এখানেই আছে সকালবেলা যারা মিস্ত্রি সেখানে চলে আসবে আমিও বেরিয়ে যাবো লাগাবে কে হ্যাঁ আটটায় আচ্ছা তাহলে এগুলো লাগিয়ে দিয়ে বন্ধ করে দিয়ে মেশিনে যা যাই হোক
এটাকে পজ করতে পারিস, লাইভ হয়ে আছে এখনো। তো দেখো এই ট্রাইপড স্ট্যান্ডটা যাবে, ফোনটা যাবে, ফোনটা কার আমি এখনো জানি না। ট্রাইপড স্ট্যান্ডটা মোস্টলি অয়নের। না, ট্রাইপড স্ট্যান্ডটা পিআর ডিপার্টমেন্ট থেকে গেছে। আচ্ছা, ক্লোজ
ক্লোজ, ওটা ইয়ার ক্লোজ আসছে। এটা কি
অয়নকে ফোন করতো। অয়ন,
আমার ফোন নাম্বার দেখ তো। আমার
অয়ন তো এই তো বাইরে
বাইরেই
দাঁড়িয়ে
দাঁড়িয়ে
আছে।
আছে ওই ইয়েটা।
এই তো খাবার দিচ্ছে।
হ্যাঁ খাবার দিচ্ছে, হ্যাঁ।
হ্যাঁ, খাবার দিচ্ছে।
হাইট লাইভ ভিডিও রিটার্স